And welcome everybody to this week's exciting episode.
Old Mrs. Ruppercut had a rough cut punt. Not a punt cut rough, but a rough cut punt. Short at the stern, wide at the bean. Old Mrs. Ruppercut had a rough cut punt.
Very good.
Yeah.
Very dangerous.
Very dangerous tongue twister there. I almost slipped up, but, you know, I had to keep going through.
I think you did a very good job.
Yeah, I got some more.
I am waiting for the one that makes me get the bleep machine out.
No, not yet. No, not yet. There's one or two that are a bit dicey, but I think that's the one with the worst word to censor if I was to slip up.
Well, the one you just did?
Yeah.
Yeah,
So
definitely.
I think we're in the clear.
Yeah.
I quite like this doing tongue twisters at the start.
Yeah?
Make sure people are listening.
It's given you some direction the last couple of weeks, definitely. You're always like, I don't know what to do for an intro.
Yeah. I've got two more of these bad boys.
Oh, okay. We're fine for the next 2 weeks then.
Yeah. It's also like, it kind of reminds me of when people are training their voice and stuff, and they're like, "How now, brown cow?" It's like,
Yeah.
It's kind of like my tongue twisters.
Yeah, the old voice exercise. The singers do that. They go do weird stuff.
But yeah,
I bet Freddie Mercury was good at that.
God, I bet he was. Yeah. I used to love that when he used to reach out to the crowd and nail.
Yeah, it was always a good bit of the show, wasn't it?
Yeah, impressive voice.
Yeah. That's a very nice hat you're wearing today, by the way.
Oh, thanks, buddy. Available now on my mercher.
Paranormalityuk.mymercher.com.
Yep, black beanie with a bit of white writing on it. Clear as day. Paranormality UK. That rhymed. Didn't mean it to be. You can pick one up too on our website. I'm not good at remembering the full website like you are. I just know it's my mercher. And
You can remember our name, though. It's paranormalityuk.mymercher.com.
Oh, is that all it is?
Yeah.
What he said.
Yeah, there you go. It looks like a nice warm hat, anyway.
Oh, it's very warm, very soft, very cozy.
Go pick ones for yourself.
Yeah, have a look.
Only available in black.
Yeah, we got some good stuff on there at the moment.
We
so
do.
Check it out.
We do. And most of it's in black. Which
Yeah.
fits with today's episode, because today's episode is entitled, Are We Living in a Black Hole?
Yes.
Yes. That's a very bold statement to make. My first assumption was no. Do you want to know why?
Yes, please do tell.
Okay, so when you look at a black hole, as I explained before in previous episodes, go and check them out if you haven't checked them out already. Particularly the white holes episode, because that will make this one make more sense.
Yes, enjoy Pirates White Hole.
Again. So, yeah, a black hole is essentially a point of infinite density in space. Yeah?
Yes.
Right? And space itself is a vast sea of pretty much nothingness. There's a lot of open space. And open space cannot essentially be infinite density. They are not one and the same thing.
Yes, no, I see what you're saying. Yeah.
So how is this theory circulated, and how is it gaining momentum?
I mean, I've not heard of this theory until just now.
Now, when I come up with it, yeah. Well, I've heard of it maybe last couple of years or so. I don't know who came up with this idea, but I've been watching Royal Institute videos on YouTube again. I know you're going to go, come on, look at you, mate.
Yeah, what a nerd.
I'm a geek. And I came across one by a guy named James Beacham. I don't know if he's a professor or a doctor or you know, exactly what qualifications he's got, but he works at CERN.
Oh, CERN.
CERN. Ooh, scary place. Is
The
it going to end the world?
It's the thing that Americans are concerned about.
Oh, nice one.
yeah,
well
yeah.
done. Yeah, well, they kind of are, yeah. Every time they switch it on and do some, like, colliding.
Yeah.
What you'd call that?
Hadron colliding.
Hadron colliding.
Bashing atoms together.
But yeah, smashing atoms together. Yeah, every time they do that, the Americans will go, no, they're going to bring about the end of the world. And then the next day, the sun rises and everybody goes, oh, that didn't happen.
Yeah. It's like when the world was meant to end in 2012.
Yeah.
Yeah,
and 2020.
Yeah, true.
Yeah, and countless other times.
Yeah.
But yeah, so James Beacham, he works at CERN, is a scientist, an actual working, functioning, practicing scientist, and he was invited to the Royal Institute to give probably more than one lecture, but this is the one that I was focusing on, and it was called The Other End of a Black Hole. And in this video, he asked the question, are we living inside a black hole?
Is this going to be one of them things when people are like, oh, we're living in a simulation? And there's no evidence to or for kind of thing. It's all like...
No, we got a little bit more grasp on this one.
Okay. Because I've always been confused by, are we living in a simulation?
Yeah, same here. I don't like that at all.
So
That's the problem with like philosophy versus physics. Is philosophy, they ask difficult questions and word it in difficult ways that you can't answer them. And physics asks difficult questions and lists them in difficult ways, but there is calculations and mathematics that you can actually do to support or blow it out of water.
Yeah, true.
You know, whereas philosophy is very much like, I could be right and you could also be right with a completely opposite theory. And I hate that about philosophy.
You've
So.
already annoyed me. We could both be right.
Good. But anyway, let's go. Let's ignore black holes for just a second and look at space and the size of the universe and the edge of the universe. So, Josh, tell me, how big is the universe?
Infinite.
Infinite.
Yeah.
That's a very good answer, and it's quite possibly true. Even Einstein said, what did he say? There are only two things that are infinite. One is the universe. The second is human stupidity. And I'm not sure about the universe. Good quote, eh?
Yeah, that is actually quite good, to be fair.
So the universe as we know it, or the known universe, what we can see when we look out in any direction, all we can see, the most distant, is 46.5 billion light years.
So that's as far as we can see.
That's as far as we can see.
Is that with the John McAvoy telescope, or whatever it is?
With any telescope, even with like radio telescopes and stuff, you can't get any more information from outside of this bubble that's all around us that is 93 million miles all the way across, 93 billion light years all across, not miles. It's 93 billion light years in a sphere all around us, and we can't see any further than that 46.5 billion light years. And the reason is, now, back in my white holes episode, I explained that my theory is that there are these white holes that look exactly the same as black holes, which is why you can't see them, and they're expanding space in this higgledy-piggledy... it's expanding and contracting. You know, the white holes are making it expand, the black holes are making it contract. You know, and it's creating this sort of pattern like a neural network in galaxies, you know, that flows around. But that is not the standard model. The standard model is that space itself is just expanding everywhere, in every direction, all at the same time. And when you get out to 93 billion light years... That's a lot of space between you and that edge of the universe, you know, 46.5 billion light years. That's a lot of space.
Yeah.
And that's a lot of expansion. So anything beyond that, we can't see it because the light produced from anything beyond that can never reach us.
Yeah.
Because as the light is travelling towards us, space is expanding, so that light has always ever got more space to travel through. Like an ant walking across a balloon. If the balloon is completely deflated and it's just lying flat on a table, the ant could walk across that balloon in 2 seconds.
Yeah, quick.
Yeah, exactly. But yeah, if the ant is on the balloon when you start blowing it up, the ant's got ever increasing amount of distance to travel to get to the other side. Yeah, as the balloon is expanding, as he's walking over it, you know, he's always looking at a horizon, if you like, that's expanding, and no matter how fast he goes, he's never going to get to the other side until the balloon bursts.
Yeah. Well, the universe can't burst, can it? Or can it?
Not that we know of. We don't know. That is the thing. But that is the reason why we have this 93 billion light year event horizon. Yeah, an event horizon technically is a point at which space-time is flowing at a rate light cannot exceed. Yeah? So the space-time outside of 93 billion light years is expanding so fast, there's so much of it, that any light coming back the other way in towards us is never going to cross all that space to actually reach our telescopes or our eyeballs. It's never going to happen. There's quite possibly an infinite space of universe of stuff out there, more galaxies, more planets, more suns. We'll never know where they are or what they look like, because that light is never going to reach us.
Yeah. I see what you're
Because
saying.
of this event horizon.
Great film.
Good film. Yeah, very good film. Yeah, we won't talk about Event Horizon. It's a scary film. But black holes also have an event horizon.
Okay.
Now, the event horizon of a black hole is the point at which light cannot escape the black hole. Okay? And the reason for this is because space-time is falling into the black hole, and the event horizon is the point at which space-time is entering the black hole faster than the speed of light. So any light that goes in there can't get out because of this, the point at which space-time is flowing at a rate light cannot exceed.
So space is forever expanding,
Yeah.
but black holes are taking space.
Yes. And compressing it down into an infinitely dense point in space. The actual event horizon is not the black hole itself. It's just the product of the black hole, or the product of its mechanism, which means it's always sucking in space. And if you were to cross that line, space would be carrying you in, and no matter how much rocket fuel you've got, you can never boost yourself back out of it.
Yeah.
Because space-time is just carrying you inwards.
So your theory of white holes would be expanding space.
Yes, infinitely expanding space.
So if it's not for your theory, do they know what is actually expanding space? Is it just happening and they...
The Big Bang is the common theory on it, is that the Big Bang started, like literally microseconds after the Big Bang, was this vast expansion.
Okay.
And they think that it's expanded, but it's slowing down, or it's slowed down, but it's still expanding from that initial explosion of the Big Bang. If an explosion is what is technically correct to call it, I don't know. But that's what the theory goes, is basically the Big Bang caused it, and it's just been expanding ever since.
Okay. I'm with you. Makes me like your white holes theory more.
Yeah?
Yeah, it sounds cooler than just the Big Bang. Because I imagine there's other people that associate the Big Bang with the TV show, The Big Bang Theory.
Yeah.
So the white holes theory just sounds a little bit cooler to me.
Yeah.
And most things have an opposite, don't they? You've got light and dark.
Yeah.
So it makes
black holes and white
sense,
holes. Yeah.
yeah.
Like I say, and I think that, I don't want to back up my theory yet, because it is going to come back in at the end of the episode.
Okay, save it then. Yeah, right.
Okay, yeah. So yeah, black holes. All right. So we've discussed that event horizon. So what would it actually be like if we went into a black hole?
Spaghetti.
Spaghetti is a good word. That is spaghettification is mostly ascribed to smaller black holes. Yeah, if we were, say, to approach a black hole that was around about the same size as the sun, you'd have a very, very violent approach. The gravity as it sucks you in would literally, like you say, spaghettify you. So if your feet were closer to the black hole than what your head was, your feet would, your legs would just stretch out infinitely as spaghetti, followed by the rest of your body and then your head, and yeah, you'd just be a big, long, thin piece of spaghetti getting wound into the black hole. But scientists do think that some of the really big black holes, the supermassive black holes, like the center of the galaxy style ones, some of these are bigger than our solar system. Some of them even make our solar system look like a grain of sand up against them. You know, literally a tiny little thing. And, you know, the black hole is just so enormous, it would swallow the entire solar system and not even burp. You know what I mean? And you can't get your head around that size, that kind of size, that scale is ridiculous.
Yeah.
It's hard enough to even imagine the distance between Earth and Pluto.
I don't even know what the
I think that's something like 49 astronomical units. So an astronomical unit is the distance from the Sun to the Earth, which is about 93 million miles, 150 million kilometres. And Pluto is about, I think it's either 47 or 49 times that.
Oh, right. Fair distance then.
Yeah.
Was it you that said that Pluto hasn't gone round the Sun once, or it only...
Since we discovered it, no.
Hasn't gone round the Sun?
No, it's only done about half a circuit, I think, so far.
I mean, that in itself shows you the scale of the distance of everything.
Yeah.
That is nuts. Do you still think Pluto... I don't mean to keep sidetracking you. Do you think Pluto deserves to be a planet? Or
Yes.
do you... Yeah.
Yeah.
Because it was always my favourite planet.
Yeah, I know, same here.
And now it's just a dwarf planet.
The only thing the only box it didn't tick was that it didn't clear space around it, because it's a small planet in what we call the Kuiper belt, which is kind of like an asteroid belt, just like really, really far out. And if it had gained more mass, it would have sucked in all of those asteroids,
Right.
and that would then give it the classification of a planet. But because it didn't do that, it didn't clear the belt around it. And it's a hell of a belt to clear, to be fair, isn't it? So it never did. But it did have enough mass to make itself round. It did attract moons, 5 of them. But it didn't clear the space around it. So technically, dwarf planet rather than a planet. But I still think it's a planet. I think it should be reclassified.
I think so too. Because now Saturn's my favourite.
Saturn's always been a good one. It's a good one to look at through a telescope as well. But black holes. We're travelling into a black hole. Okay, so what would it be like? Well, let's imagine we got a spaceship and we're travelling towards this black hole. Now, you don't travel in space straight lines in space. You travel in orbits. You're traveling in orbits because space itself is curved. So what we want to do is we want to get close enough to this black hole that we can reach out of our spacecraft with a little scoop and scoop up a bit of black hole and see what makes it. Yeah? So to do that, what we've got to do, because we're already hurtling towards this black hole really, really quickly, but at our current trajectory, we're going to go round the back of it, and we're going to come back out the other side, and we're going to head back towards Earth. Safe trajectory. But we're not getting close enough to that black hole. So what we need to do is we need to spin our spacecraft round, fire the thrusters, what's known as retrograde, so in the direction that we're travelling, which will slow us down, which will bring that curve in towards the black hole, closer to it. Unfortunately, we fired them for a couple of seconds too long, and now we're actually going in.
Okay.
Right. So hold on to your hats. That's a very nice hat. So
Holding on.
as we're travelling towards this black hole, we've got like a compass. Yeah, you know, like a compass that would say north, south, east, and west.
Yeah.
This one is a gravitational compass. It's saying, yes, we're heading directly towards a black hole. Right, but if I turn around and point it to the back of the ship, it's saying, no, black hole's behind you. Brilliant, we're all right. Up until the point that it doesn't. Because once we cross that event horizon, no matter which way we point that compass, it's going to say that we're heading straight into a black hole. Because the space that we're travelling on, the space-time, is flowing into the black hole, and no matter how much we fire our thrusters, we're never going to get enough momentum to go against the grain of the space. So it's closing in. We're closing into this black hole. Now, the point is, what is the difference between that event horizon of the black hole and the event horizon of the entire universe. There isn't a difference. You're doing exactly the same thing. Yeah?
Yeah, but the only thing is, surely, if we're going into a black hole, the black hole is impending doom. That's it. That's done.
Is it though?
Well, I would assume so. If
Well, we
get
don't
all-
know because no one can go into a black hole. And if you did go into a black hole, you can't send your results out.
So we don't know what is in a black hole.
No, we can only theorize.
Okay. So theorizing that we don't die in a black hole, ultimately there is no real difference between event horizon there, event horizon here.
Yeah.
It is the same.
It's
'cause you're
basically the
still-
same thing. Because, yeah, once you cross that event horizon into the black hole, you can't turn around and come back out. Because, again, I mean, it's slightly different to the edge of the universe theory, is that the edge of the universe is expanding away from you. Well, I guess it's the same sort of difference in the black hole. It's just the space is coming in, but it's effectively the same thing. Because light still can't travel past it.
I mean, that in itself is because I was always brought up with Star Wars, so light always defeats dark. And if you've got something so dark that light cannot escape from it, that to me is a no-no. Like, don't go into
Don't
a
go
black
in there,
hole.
yeah. But
Like-
who knows? Maybe we're already in one. And this is how he backs his up.
Is this the meat? This is the juicy part of...
Sort of, yeah.
Okay.
Right, so he came up with this equation. I didn't write it down because it doesn't really matter. But he in his video presentation, he starts going on about, all right, how could we make a black hole, or how much compression would we need to put into matter to create a black hole? Let's try and make a black hole out of you. Yeah. We'd take all of the mass in your body and crush it down to the levels that a black hole would need to be. The black hole that you would create would be around about the size of an atom.
Yeah, it's not going to be big.
It's not going to do a lot, is it?
No. Be a bit dust.
No, exactly. So he said, right, okay, what if we took bigger than that? Let's think the Earth. Let's take the size of the Earth, crush that down, all the matter of the Earth into the density of a black hole. It'd be about the size of a golf ball.
Yeah, in space it's not going to do much.
Still not doing much, is it? Even the sun, that would only be about the size of a basketball if you crush that down.
Yeah, I'm following.
Yeah?
Yeah.
So we went, right, okay, let's go bigger. Let's go the known universe. If we took all of the matter in the universe, all the planets, all the stars, all the dust, the nebula, everything that's floating around in space, all the black holes, all the dark matter that I don't believe in, and put that into our equation and figure out how big the black hole would be, how big do you reckon it'd be?
Size of a football pitch.
No. About 1.5 times the size of the known universe.
Oh, I was way off.
Yeah.
I was just trying to go by the golf ball thing.
So he thought, I must have got something wrong. I'll crunch my numbers again. I'll take half of everything out. All right. So maybe I've massively overestimated how much matter is in the actual known universe, and would take half of it out. Run the equation again. What effect do you think that had?
So he's taking everything in the known universe
Everything.
and crushing it. So is that the 46
Yeah. All
billion light years?
Yeah. Well, all 93 billion light
93.
years.
That's what he's
All
crushing
around,
down.
and he's crushing it into a black hole.
And that creates the size of our
1.5 times the size of our known universe. So again, like you say, he halved the numbers and he recalculated, and it came out just over the size of the known universe.
Okay. So that's his theory for thinking that we could be living in a black hole.
Why not?
I mean, I kind of get what he's trying to do, but it just doesn't. I don't know, because that would be saying that the space that we know
Yeah.
is
the black hole.
inside of a black hole.
Yeah.
But there's black holes.
We don't know what happens inside of a black hole. So, like, in theory, space coming in could be expanding our known universe, but we can't see beyond that to see what it is that's actually contributing. Do you know what I mean? It's the same thing as the universe expanding. That event horizon is still there. You still can't cross it. So, you know, in theory, it is a plausible suggestion that black holes contain entire universes. And there may be multiple universes in our own universe, all contained within different black holes. Just a sliding scale. You know, we're the macroscopic. A universe inside a black hole could be microscopic one.
I'll tell you what I like about that theory.
Go for it.
Is when everyone talks about extraterrestrials and aliens coming to Earth,
Yeah.
and things like that. And I've always said, how is it possible that they travel all of those light years, billions and billions of light years, and then they just get to Earth and they crash land? It doesn't make sense. But then with this guy's theory, who's to say that aliens aren't traveling through black holes to get to different places? And it's almost like teleportation in a way. Almost.
But there again, and then again, you see, if this theory holds up, it then backs up my white holes theory. Because space isn't necessarily ever expanding outwards in a circle from, you know, every point everywhere. In theory, we've got space traveling inwards, which is expanding it. And then my white holes would be expanding it as well. Or maybe the space is created through the black hole and then comes out of a white hole that's inside the black hole in our universe. Do you know what I mean? And that's why we get this convection zone style expansion. Like, we get that sort of that network of galaxies that looks like a neural pathway or something like that. You know, it looks like blood vessels almost, all traveling towards some central super cluster of galaxies. And then you'll see vast spaces in between that where space is expanding and there's no galaxies in there. It's just empty space.
Really?
Yeah.
Just empty space?
Yeah.
No stars or anything?
No stars, no galaxies. And there's billions of light years, or, you know, millions of light years of just empty space before you hit the next galaxy.
That's interesting.
And the galaxies all travel down these veins towards a supercluster. And like I say, my theory holds up in that kind of scenario, because that's how space is expanded. We're going back to that space expanding from white holes, going back into black holes, and supplying another universe with more matter, more universe.
It's kind of like that that graphic design you see of like the tunnel, where it's almost like, I can't even, do you know the one I mean?
The ever expanding pictures that you see.
No, it's like it's almost like a disc at the front, and then it goes down into like a tube, like a tunnel.
Yeah,
and then
yeah.
it's like a funnel at the bottom again. So it's
Yeah,
kind
yeah,
of,
like a wormhole sort of thing.
Oh yeah, I guess it
Yeah.
must be a wormhole that I've seen.
Yeah.
But in theory, is that the kind of the same thing, like a wormhole, where it's,
Yeah, sort of, yeah.
like
Yeah.
if you're getting holes within holes, and
Yeah, if you were to say that space is a piece of paper, and then you fold it, so one side of it is hovering, one half of it is hovering above the other half, then you created a wormhole between the two halves, yeah? That's what you're saying.
yeah.
One would be the black hole, and the other would be the white hole. It's sucking in space from one side, throwing it out the other, but it's in a closed loop. It's in a closed circuit. So that's like I say, it's a convection zone. Like your porridge, I think I used as an example in the last episode. The porridge is hot. It comes to the surface. It cools. It spreads out, and then it seeps back down in these sort of higgledy-piggledy veins, doesn't it? They're known as convection zones. And space, to me, to my idea, is just one giant three-dimensional convection zone. Where it's throwing out space in all directions, but sucking it in from all directions in another place.
Well, I'm going to throw a spanner in the works. Where did different dimensions come into this?
Well, inside a black hole is another dimension, isn't it?
So there'd be different dimensions within different black holes.
Yeah. And different universes. I mean, this holds up the multiverse theory as well, doesn't it?
Oh, Avengers style.
Rather than each universe being on the outside of each other, you know, like floating around or tessellating or something like that, like a beehive, they could be actually within one another. We could be in a black hole in somebody else's universe as part of their multiverse. And then there's a black hole at the center of our galaxy that could hold another universe in this sliding scale of universes.
Yeah. You've opened another can of worms. It's almost like another question we'll never know the answer to.
Well, we will never know the answer, but all we can do is theorize over it. And like I said, when I first came across this theory, I was like, no, can't happen. No. Infinite points of density, massive open space, not the same thing. But when you look at the evidence and when it's presented to you in a certain way, I can see what people are saying.
But yes, well, I was just going to say then, we've got the sun. So that wouldn't be able to have light inside a black hole. But then if we're all in a black hole, there's no difference. It doesn't make... Someone looking it out from the outside... It's
only the event horizon that the light can't pass through. Once you're actually in the heart of the black hole, light's going to travel around it as normal. It's just where space-time is condensing, if you like, at that event horizon, at that point where it's traveling faster than the speed of light to expand, because there's so much of that space coming into the black hole. It's essentially the same as the universe expanding from within. Do you know what I mean?
And with your multiverse theory... Is there a universe in which the Earth could be flat?
No.
Okay. That is a constant
that goes
that will not
against
change.
all conventional physics, I'm afraid.
Okay. Yeah. Okay, fair enough. Yeah, I get it. I was just trying to give the flat earthers another glimmer of hope.
No, there's no hope for flat earthers, I'm afraid.
No. Okay.
No,
well,
so,
my brain has been melted. But
hopefully not too much.
Not as bad as last time. I do get what you're saying. It's a very interesting theory, and because of the alien travel and things like that my brain went to. Not so much yours, because you seem to be much more of a like science, physics. It kind of drives you. Like you like to know the ins and outs of this.
I like mysteries, and I like paranormal and supernatural stuff, but I like to be able to get my head around it in some way as well. Yes.
Whereas my brain is almost like ADHD, and it's like, can aliens travel through black holes? So very different ends of the spectrum there, but I like it.
Again, like I said, with the whole, like, if you were to travel into a small black hole, it will almost be certain death, but big ones, not so much. Well, maybe those big black holes do have accessible universes that we could, in theory, travel to. We'd never be able to travel back from them.
Yeah. A few of my mates have never travelled back from a big hole. You know what I'm saying, boys? But no, it's a very good theory. I kind of really like it, to be fair. The more I think about it and try and wrap my head around it, I quite like the idea of being in a black hole.
A whole universe just contained within a black hole.
And then the nerd in me is like, ooh, multiverse. Oh. You know what? Straight into the scale, mate. I'm going to give it a solid 8.8.
8.8.
Yeah.
Oh, fair play.
Yeah, because at the start I wasn't sure where you were going with it, and my brain's not as tuned in to physics as yours. So at the start I was a bit confused, but then the more I thought about it, and the more I got sidetracked by aliens and other things, I thought, no, this is good. I've got a good feeling about this theory. And then some of your examples, dulling it down for people like me that don't understand it, I thought made sense. So yeah, I'm going to give it an 8.8. Final answer.
Yeah?
Yeah.
I'm going to give it a 9.2 then, and we'll flatten it out at 9.
Yeah, that's good. That's a good one.
Yeah.
I mean, I feel like I need to come out with some sort of crazy theory to rival this physics.
I think you should. You should.
What about green holes? Are they a thing? Yeah, just...
A green hole is not to do with space.
Oh. I don't know. Yeah, it's interesting. It's very, very interesting. Food for thought.
It is food for thought. But yeah, that is... I am slightly obsessed with black holes, I know.
Yeah. And white holes, yeah.
And whenever the new theory is presented to me, I like to try and understand it and then try and relay it to you in a way that you can understand it. And that helps me to understand it even more.
Yeah.
Because I'm not great with the equations in physics. And like I said, there was an equation that the guy presented that... about how to make a black hole out of like you or the Earth or the whole universe and that sort of thing. I didn't bother write it down because I can't peer review it myself. I don't know if it works or not. I'm just going by his word. But it was a very good episode. And if you at home listening to this want more proof of this, go and check it out yourself. James Beacham, The Other End of a Black Hole by Royal Institute on YouTube. Very good presentation. It's about an hour long, a bit longer than mine.
Yeah.
But very compelling, very convincing. He's American.
Yeah, cool. Yeah, the Americans always seem to have like the crazy conspiracy theorists and certain ideas and things. But I mean, you can't hate on it. I suppose Americans are always... I always feel like Americans are like always very forward thinking.
He's an American that works at CERN, so he's got to have a bit about him, hasn't he?
Yeah. I mean, just because their healthcare and gun policies are rubbish, but I'm not going to get into that.
No, we're not going into that in this episode.
But no, there are some very, very smart American people that do seem to have brains that can wrap their heads around this stuff.
Yeah.
So, yeah, I mean, he's gone to, what is it, Sweden, you say, that the CERN is?
I think it's...
Switzerland?
Switzerland. Yeah, not Sweden. Switzerland.
No, Switzerland.
Yeah, border. Is it France and Switzerland or something like that, I think?
Yeah, so he's obviously wanting to find out more about this kind of thing and
Yeah.
stuff, isn't he? So, no, interesting guy. I might check that out for myself.
It is a good episode. I don't expect you to carry on watching Royal Institute, but
definitely not.
That one is definitely worth taking a look if you're interested in black holes at all, which obviously I am. And that's that. Yeah.
Does anyone else believe in any black hole theories, or have they seen a black hole through a telescope? Let us know.
You can't see a black hole through a telescope. We have taken a picture of a couple of black holes. It's difficult. We have taken pictures of the one at the center of our galaxy, Sagittarius A star, but there's so much like dust and clouds of gas and stuff in the way that we actually found it easier to take a picture of a black hole in another galaxy that's something like 65 million light years away. It's called M87. So we took that because we're looking at that galaxy from essentially the top down. We're not looking through all that dust, which is what we're looking when we look at our own black hole. So it was actually easier to get a picture of one 60-odd million times further away than it was to get our own.
What is the name of that telescope? Is it the James McAvoy telescope or something?
The one that took the picture of the black hole?
There's a specific telescope that's got a name.
The James Webb telescope you're thinking of, but that's not what took the picture of the black hole.
No?
No. We got the picture of the black hole with radio telescopes all over the globe.
Right.
Because essentially, to take a picture of a black hole, you need an Earth-sized telescope.
Jiminy crickets.
So what they did was used an array of telescopes from dotted around here, there, and everywhere, and then compiled all the results and created the picture from what's known as the Event Horizon Telescope, because it's literally the size of the world.
That's pretty damn cool.
Yeah, very clever, isn't it, what these scientists get up to?
Yeah. Yeah, shout out to scientists.
Yeah. And, well, since you're wearing some merch, we might as well plug the merch this week. We've already plugged it a couple of times at the start of the episode. I don't like doing that. I curse myself for doing that. I like to keep a call for action at the end of the episode. So if you've actually made it this far through the episode, you deserve some merch. Go and treat yourself.
Go check it out.
Paranormalityuk.mymercher.com.
You didn't say it Welsh that time. I didn't like it.
I never say it Welsh.
You bloody do. My mercher. Go
That's
back
not
and
Welsh,
listen.
that's just country.
No, you. So there's people out there that are going to agree with me here, and they'll say sometimes pirate sounds a little bit Welsh in certain words, and there's been a few times you've said my mercher, and other people have picked up on it as well. But
My mercher. That'd be Welsh. My mercher.
Oh yeah, maybe it was country then. Yeah, that does sound more Welsh than what I was doing, to be fair. But yeah, check out our merch.
Yeah,
It's
we got
very,
hats,
very
we
good.
got t-shirts, we got hoodies. We've even got one of these cool little research books that you can buy for yourself. That I'm now going to hand over to Josh for his
for my research
next week.
Tea towels.
Do we have tea towels? Yeah. Well, I think we've even actually had a couple of requests for gym vests.
Yes, we have.
So I've handed that over to Polar Bear. He's going to get on that. We will be getting some gym vests with the logo on, only in black though. So I hope you like
Johnny
wearing.
Cash style.
Yeah, I hope you like wearing black at the gym.
Yeah,
Yeah,
it's flattering.
it is. It goes with everything.
It does, yeah.
Yeah. And until next week, I've been Pirate.
I'm Josh.
This has been Paranormality UK. Ta-ta.
Ta-ta.